7.4, we have properties of logs. Now, think of the same properties that you have at exponents, because remember, logs are inverses of exponents. Those same properties of exponents, just like if I had x squared times x to the third, I'm adding those together and I get x to the fifth. Or if I have x to the sixth over x to the fourth, I subtract those and I get x squared. Those same type of properties are still being applied to logs. If I'm taking the log of something, my base stays the same. But if I'm multiplying in between these two numbers, I can open them up, so log with both, and add. Or if I'm dividing, it'd be subtracting between. Or, remember if we had something like this, x squared to the third, that would give me, I multiply it, that becomes x to the sixth. If I have a power, I can bring it out in front of the log. So if I have something like this, I wanted to condense it and write it as one single log. My log base does not change. My base 4 does not change. This becomes, because of subtraction, the first number goes on top, the second number goes on bottom. And then I have log base 4 of 16 would be equal to x. You could solve this in your head because it's saying 4 raised to what number is equal to 16, or else you can type that in your calculator and that's also going to be equal to 2. But for right now, it's just asking to write as one single logarithm, so that's going to be my answer. Here, first thing I'm going to do is move anything that's multiplying as an exponent. So that would become log base 2 x squared plus log base 2 y to the fifth. Since I'm adding, I only should be writing log base 2 one time. When I'm writing as a single log, writing the log just one time. And I would be multiplying these two together. Like that. I want you to pause and try to do the other two by yourself. So this one, since it's adding, I can simplify this now. You should always simplify once you condense it. This becomes 15x squared. Here the 2 comes as an exponent, so that becomes x squared. 6 squared is 36. Since I'm subtracting, it's dividing. So 36 divided by 4. This, whenever you take the log base and the number is the same, it would be 1. So what if I want you to expand? If I'm expanding using those same properties. This log base 10 is going to be the same every time. So wherever there's multiplying, it might be helpful if you do multiplying and make sure to know where the dividing is. Can't really see, but we're going to have log 4. So that first one is being multiplied. So I'm adding log x because those are multiplying. Anything on top should be positive. Anything on bottom should have subtraction. Since this is on bottom of the fraction, I would subtract log y, and that would be my final answer. So what if I have something like this? Well, this log base 9 x to the fourth would subtract log base 9 of 729. I have to still move this out in front. So this becomes 4 log base x minus. Now, if you have a number, so if I have a number like this, again, if you don't have the log number, you would want to do log of your big divided by log of your base, or else go to math and find your base. I can simplify this just to be 3. If you have just a number, you should see if you can simplify it to be a nice number. That would be my final answer. I want you to try to do this next one by yourself. So for C, it's division, so there should be subtracting here. Neither of these are nice numbers, so this would be my final answer. For D, when I expand it, so I have a log base 3 of 9, since there's multiplying here, that becomes adding. The 5 should come out in front of just the x value. If you put that in your calculator, you would get 2. And finally, I've actually already talked about the change of base. Right now, you should attempt to put all of these in your calculator to see what number you get out. Either with the change of base, so log of the big number divided by log of base, or if you have that special button. So you should always try to put them in a fraction. If they can't, you should round to 4 decimal points. This last one, be aware that this 9 would have moved up because of the 6, so that's why I have a 0. I still have to represent that 0, saying that, yep, I did round it to my 4th decimal spot. That 4th decimal spot was a 0. That's it. That's the properties of logarithms.